Hi, 8th grade. We are going to go over 2.7. 2.7 is all about dilations. In class, we talk about the word dilation, and you probably have heard this before about when your eyes dilate, it means your pupils grow or shrink. So when you shine a light in your eyes, your pupils get smaller, and when you turn off the lights off, then the pupils grow larger. So similarly, shapes also can grow and shrink. And just like your pupils, there is a center of dilation. So for example, on your pupil doesn't move, it just stays where it's at, but the center right there is where it either gets smaller or gets bigger. Okay, so just like shapes, or just like pupils, shapes also have a center of dilation. Now, usually the center of dilation is the origin, and that's mainly where it's going to be in this whole lesson. So when shapes are growing, we actually don't call it growing, we call it enlargement. Okay, so an enlargement is the more correct way of saying that they grew. And then instead of saying shrinking, we say reduction, okay? So they either can shrink or grow, but we'll call it enlarging or reducing or reduction, okay? Now, something else I need you guys to know is that the rate at which something grows or shrinks is called the scale factor, okay? Now, scale factor, we abbreviate it with a K. K means scale factor. And something you also need to know is if the scale factor is a fraction, the shape will shrink. If the scale factor is a whole number, or I guess I should say whole integer, because it can be a negative number as well. If it's a whole number, then it'll grow. Okay, so scale factor, if it's a fraction or a decimal, it'll shrink. If it's a whole number, it'll grow. Before we even get started into those, let's go ahead and just look at these simple ones. Tell whether the blue figure is a dilation of the red figure. This is a dilation. I can tell that the red figure shrunk down to that blue figure. The center of dilation would be somewhere back there. This is not a dilation. That is a translation. It moved over to there. This is not a dilation. It did not shrink or grow. That is a reflection. This is a dilation. The square shrunk to this little one. Okay? Now, here's where I wanted to talk about the scale factor, whole numbers, and all that good stuff. So, let's go and start over here. We're looking at this picture. I have got two shapes. I can tell that the blue one is the image and that the red one is the original because the blue one has prime markings. So I can see that my little red shape grew into this big shape. So it was an enlargement. This is a dilation. The center of dilation is the origin because I can draw a line through every point to the origin. So B to B could go through the origin, C to C could go through the origin. Okay, that's all good news. Now if I said find the scale factor, what I'm asking is how much did it grow or shrink by? The first thing you want to do is pick a point. I'm going to pick A. A is 0, 2. Now I'm going to go pick A prime's counterpart. So it'd be up there, it's 0, 6. Now here's what you got to do. You want to ask yourself, 2 times what got you that number? Now this one's pretty simple. 2 times 3 would get you 6. Now 0 times 3 is also 0. But I want you guys to understand is if I'm multiplying these by a whole number, my scale factor is 3. That means it grew by 3, okay? Now we only did 1 point, but this will work for every point. For example, B is 2, 2. And then b prime is 6, 6. Did I multiply my original by 3 to get 6 and 6? Yes, I did. Okay, let's check C, make sure it works. C is 2, 0, and C prime is 6, 0. So, did I multiply this by 3 and this by 3 to get 6 and 0? Yes, I did. So I would say scale factor equals 3. Let's find one where it shrunk. So I'm going to look at this guy right now. Let me go ahead and get my sheet of paper. Okay. I can tell this one is a reduction because the original doesn't have the prime markings. This one would be the second one, okay? These guys. So I can also tell that the center of dilation is the origin because I can draw a line straight through the y and the origin, the x and the x in the origin. I mean, if I could draw a straight line. And the WW and the Z through Z, okay? So far, so good. Now I gotta find the scale factor. Let's start at x. The coordinates for x are, oh, and also be super careful, guys. A lot of kids are gonna say 1, 2, -2, up 1, 2, 3, 4, but no, that's not the coordinates. The scale of the actual coordinate grid is going by 2's. See how that was -6 right there? So this is -2, -4, -6. This is 2, 4, 6, 8, 10. Be super, super careful on that. So the coordinates for x are -4, -8, or no, +8, sorry. -4, 8. Now let's go do the coordinates for x prime. X prime is -2, up 4. Now, let's ask ourselves, how did I get from -4 to -2? I want to remind you that if a scale factor is being multiplied by a whole number, it grows. But did my shape grow? No, it shrunk. So if it's being multiplied by a fraction, then it will shrink. So what fraction could I multiply -4 by to get -2? I want you guys to remember something else. Kind of unrelated, but related. If I'm multiplying, let me just make a random multiplication problem right here. How about 2x plus 4, and it's all being multiplied by 1/2. I want to remind you that if I'm multiplying these through the distributive property, it's just like saying 2 times 1/2 is the same thing as 2 divided by that 2 in the basement. Because won't 1/2 times 2 over 1 just equal 2 over 2? So isn't it kind of quicker just to say 2 over 2 now? And the same thing over here with the 4. You could say 1/2 times 4 over 1, which would get you 4 over 2. But isn't it quicker just to say 4 over 2 now? So whenever you have a 1 in the numerator, you can just take that denominator and shuffle it through there like a division problem. So my whole point of showing you this is to tell you, when you're multiplying by a fraction with 1 in the numerator, it's the same thing as just taking that bottom half and just dividing it. So going back up here, what can I multiply, that's a fraction, by 4 to get 2? Well, I know that 4 divided by 2 would also get me -2, right? And then 8 divided by 2 would also get me 4. So the scale factor is not divide by 2. The scale factor is 1/2. Take that divided by 2 and put a 1 in the numerator. So I would say that this is a dilation, it is a reduction, and the scale factor is 1/2. So all I've shown you so far is that if I am growing, the scale factor is a whole number. We find out how did I get from here to here with multiplication. If I'm shrinking, the scale factor will be a fraction. We ask ourselves, well, how did I divide to get from here to here, and then turn that into a fraction, okay? That's all this chapter basically is. Eventually we get to the point where it says use more than one sequence of transformations, So let's go ahead and just kind of look at example 4. I'm going to highlight some things for you. It says the vertices of trapezoid, the red one, is A, B, C, and D. I'm going to go and highlight that for you. The vertices of the trapezoid are this. Dilate the trapezoid with respects to the origin using a scale factor of 2. Now, they just told me the scale factor, guys. The scale factor is 2. So go through each of these points and multiply them by 2. When I do that, I'll get A prime, B prime, C prime, and D prime, which ends up being that blue shape. A prime is negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. Watch your negatives. B prime would be negative 2 comma 2. C prime would be 0 comma 2. And D prime would be 0 comma negative 2. Now if you look, those are the coordinates of the blue shape. So far all we've done is just the first half of the directions. Let's go and read the rest. Then translate it 6 units to the right and 2 units up. So you can see from here, they chose a point. Let's choose C prime. 6 units to the right and 2 units up. Ready? 1, 2, 3, 4, 5, 6. 1, 2. So C prime prime would land there. B prime, let's go ahead and count 6. 1, 2, 3, 4, 5, 6, up 2. B prime prime would land there. And so on and so forth with all of these points, okay? So you'd still go over 6, up 2, over 6, up 2, and that's how you'd get your final shape. The question is, what are the coordinates of that final shape? Now down here you can see they gave you the answer. The coordinates of the final shape are right here. But I guess that's as hard as this section really gets, is when they want you to do more than one transformation. And it's not so bad. Just take it direction by direction. And dilations are super easy. All you do is you take the scale factor that they gave you and multiply it throughout every coordinate, okay? Each of these gets a multiplication of 2. If they would have told me that the scale factor was like, I don't know, let's say the scale factor was 1/4, then I would just divide all of these by 4 to get the new one. And that would mean the shape would have shrunk, right? So pretty simple chapter. I'm not going to go through too many more, but I just want you to understand that all you're doing is multiplying the scale factor through the coordinates. Let's look at 13, 14, 15, 16, 17. We're not going to do too many of these problems, but I just want to show you how you would. A, B, C, those are the coordinates. The scale factor is 4. Remember, K is scale factor. All you're going to do is take that 4 and multiply it to each of the coordinates. So your new coordinates would be A prime is 4 comma 4, B prime would be 4 comma 16, C prime would be 12 comma 4. That's all you do. 15, the scale factor is 0.25. I know 0.25 is the same thing as 1/4, which means my shape will shrink. Just take the divide by 4 part and divide all of these by 4. Okay? G prime would be negative half, because isn't 2 over 4 the same thing as a half? So G prime would be negative half comma negative half. H prime would be negative half comma 1.5, because 6 divided by 4 would get you 1.5. So you guys, it's that simple. This one says that the scale factor is 1/3. So just take the divide by 3 part and divide all of these by 3. So my new coordinates for this shape would be Q prime would be negative 1 comma 0, because negative 3 over 3 is still negative, right? R prime would be negative 1 comma 2, because 6 divided by 3 is 2. So are you getting the point here? You're just taking the scale factor and multiplying it or dividing it throughout, okay? Scale factor is the K. That's all you're really doing, guys. 20, 21, and 22 says the blue figure is a dilation of the red figure. Identify the type of dilation and find the scale factor. Okay, so what kind of a dilation is this? Looks like prime would be my image, right? So it looks like it grew, and we call that an enlargement. So this would be a dilation, an enlargement. Now, to find the scale factor, just pick a point. I'm going to pick A and A prime. okay? And then just compare them. So A is 1, 3. A prime is 2, 6. And I know that it grew, which means I'm going to multiply by a whole number, right? 1 times what gets you 2? Well, that's easy, 2. 3 times 2 gets you 6. It worked, right? It has to be everything throughout. I'm going to assume that it works for everything else because it does tell me it is a dilation, okay? So I'm going to say the scale factor, I'm just going to say K to make it easy. K equals 2, and then I would say it is an enlargement. There we go. Let's do 21. Looks like this is a reduction, so I'd say it's a reduction. I know that because these are the prime, and that would be my image, so I started out big and I shrunk down to that. Now, once again, just go ahead and pick a point. I'm going to say x and x prime. X is -4, 4. And x prime is -1, 1. Remember, if I'm shrinking, I'm multiplying by a fraction. And when you multiply by fractions, it's the same thing as dividing by the numerator or the denominator. So let's ask ourselves, -4 divided by what gets you 1? Well, I know 4 over 4 is 1. 4 over 4 is 1. So divide by 4, how do I make that into a fraction? Just put a 1 in the numerator. So my scale factor is 1/4. Super simple, guys. Let's do 22. I can tell that this is an enlargement because it grew. I'm going to go ahead and pick J and J prime just for because they're right there, super easy. All right, J is negative, ooh, gotta be careful again, look at the scale of this. It's going by 2s. So I almost said it was -3, but it's not -3, it's 2, 4, 6. It's -6, +4. -6, +4. And then the blue J prime is, oh, see this, guys? See how it lands in the middle? That's not hard, guys. So this would be 2, 4, 6, 8, 9. So it's back 9, up 2, 4, 6. Okay, like I said, this is an enlargement. So I need to ask myself, 6 times what gets you 9? 4 times what gets you 6? Now I know some people are thinking, Mrs. Ringler, 6 times nothing gets you 9. But if I take 9 divided by 6, I get 1.5, right? So technically, 6 times 1.5 does get you 9, okay? And then 4 times 1.5 does get you 6, okay? So even though there is a fraction or a decimal, there's still that whole number, okay? And we like whole numbers. As long as they're not just a decimal or just a fraction, it will still be an enlargement. So the scale factor is 1.5, or you could say the scale factor is 1.5. Okay? A lot of kids will see that fraction right there and go say, Mrs. Ringler, I thought you said fractions means it shrinks. But yes, as long as there's that whole number with it, it's okay. It grew by 1.5. Okay? All right, guys, that's pretty much all that you really need to know for that section. The next is a quiz over 2.5 and 2.7. You can do the practice quiz on page 90 in your book. Super helpful. It's very, very similar to the actual quiz. If you have any questions, please come to class the next day and let me know. Thanks.